So tonight's kind of a two-part lesson. We're going to touch on correlations and skewed distributions, which don't have a whole lot to do with one another. But when I hear feedback from people about what they struggle with for statistics, anything with numbers or like the bell curve tends to be really difficult. So that's what I decided we were going to do tonight. Okay, so we are going to look at, do variables move together, right? That's the question that correlations answer. And then what happens when distributions become uneven, right? A bell curve is a normal distribution, but what happens when they become uneven? That's what skews the curve. And then finally, like how researchers interpret these findings. We're going to be using our sample data that we've been collecting not collecting, that we've been using to look at those. Okay. So just to refresh your mind on those, we've got two different kind of sample studies that we've been using. The Connected Campus study is measuring depression, connectedness, attendance, and GPA type things. And then the Calm Mind study that we've created is going to be measuring anxiety and confidence, study hours, mock NCE scores. And so the question that we can ask if we're looking at correlations is, do these variables in each of these studies relate to one another, right? And that's what correlations are going to tell us, is do two variables change together, right? Or are they changing independently? So we might also ask this, as X changes, does Y also change? To whatever degree that there is a change together, that's what we are going to call a correlation, okay? If you have questions, please stop me or post them in the chat as we go, because these concepts are kind of building on one another, and I want to make sure if anything's unclear that we're able to stop, okay? So important to remember with talking about correlations is that correlation does not prove that X causes Y. Okay, just because a change in one also correlates with a change in another does not mean that they cause one another. For example, ice cream sales being up and sunburns being up does not mean that ice cream consumption causes sunburns, right? Just because ice cream sales are up and sunburn cases are up doesn't mean that ice cream causes sunburn, right? There's a hidden variable here, right? The summer temperature, right? Summer temperature rising correlates with ice cream sales and correlates with sunburn, but ice cream sales and sunburn do not cause one another. Does this make sense? Correlation does not equal causation, okay? So when we're looking at correlation, there's variables that might show one of three things. A positive correlation, meaning that both increase together. A negative correlation, so as one increases, the other decreases, or no correlation, so there's no predictable relationship. Okay, so we're going to look at each of those independently. And we're also going to look at the correlation strength. So not only do they move together, but how closely do they move together? You know, there can be a weak, a moderate, a strong, or perfect, which is very rare, right? The closer the points on a plot, the stronger the relationship, okay? The strength of a relationship is measured in what we call a correlation coefficient. Coefficient is just a number that represents how strong that relationship is. Correlation coefficients are going to range between negative 1.0, which is a perfect negative correlation, anywhere from negative 1.0 all the way to positive 1.0, which is a perfect positive correlation. Zero being right in the middle means that there's no relationship. Okay, so how we arrive at correlation coefficients, we'll talk very, very briefly here in a minute. But we just need to know that that coefficient, that number that tells you how strong the relationship is never going to fall outside of -1, in between -1 and +1. Okay, pausing here. Questions? I feel like I just threw a lot of information. Is that unclear at all?
Sounds good.
Sounds good to you. Perfect. Thanks, Michelle.
I have a quick question.
Sure.
There's like some questions that will say like what if it's like a negative 85?
-85.
Yeah, or like is this ever a question or am I losing like a positive 85 and it says like what's the correlation or what's the
Okay.
I have to find like a specific question, but it will show like a number with like either a negative or a positive and the number's sometimes pretty high. Is that
So
like in relation to this?
what I would wonder, just as you're describing it, is if there's a decimal point before the 85.
Yes, probably.
Okay. If
Yep.
there is, like, let's just say there's a negative 0.85,
Okay.
right? That point negative 0.85 is between 0 and -1,
Okay.
right? Because
Yeah.
0.85 is a decimal that's less than 1,
Yes.
right?
Yes.
So if you see a number that is 85 without the decimal, then something's gone very, very wrong. Okay.
No, it has the decimal, but it's asking like, is this a strong?
Right. Yes, we're going to talk
Okay.
about that here in just a minute.
Okay. Okay. Okay.
0.85 would be a strong correlation.
Okay.
Okay.
Thank you.
Yeah. Great question. I love that you're thinking about that. Okay. So let's look at first, before we look at some actual numbers, let's look at an example of a positive correlation. Okay. Using our Calm Mind sample study. So study hours and mock exam score. So we're going to ask, is there a correlation between the amount of hours that are studied and the score on a mock exam? As study hours increase, scores also increase. So that would be a positive correlation because both variables are increasing, right? As study hours increase, so do scores. That's a positive relationship, a positive correlation. Does that make sense? If we were to plot it out on a sample scatter plot, again, this is all made up data. We see here on the bottom axis, as study hours increase from 0 to 40, the mock exam scores also increase from 40 to 100. So a strong positive correlation, R, which is how we represent our relation, our coefficient, the closer it gets to +1, the stronger the correlation. Okay, so 0.85 is close to 1, so that would be a strong positive correlation. Pausing for questions. You see on the chart how study hours increasing, mock exam score is increasing, right? We see that rise both directions. Okay. So if we're understanding what a perfect positive correlation is, R, that's the letter that represents the correlation coefficient, is going to equal +1. +1 represents a perfect positive correlation. So every time there's an increase in X, it perfectly predicts an increase in Y. So if I were to say for every hour you study, your mock exam score is going to go up 3 points every single time predictably, right? And we could put any number in there. For every 30 minutes, it's going to go up 3 points. If we could um, predictably predict that, that would be a perfect positive correlation of +1. This is very, very rare in counseling research, as you can imagine. Like to have that level of predictability is pretty much unheard of. Okay, so do we understand perfect relationship? We can predict the amount of change in each and how they're going to be affected. So let's look at a negative correlation example with the connected campus sample study. So being connected to school, like classmates, and depression symptoms. So as the level of student connection to one another increases, the depression scores decrease, right? Increase in connection equals decrease in depression scores. That's a negative relationship. As one variable increases, the other decreases. And this is what it looks like on the scatter plot. So connectedness score, if they're, I don't know how we're measuring connection, But as the connection increases from 0 all the way to 100, the depression score is decreasing. That's a negative correlation. Okay. This one has a moderate negative correlation because R is between 0.3 and negative 0.3 and negative 0.7. Because you can look here on the chart that some of the plots go down and some of them go up as they're moving down. It's not consistently moving down. That's why it would be moderate. Does that make sense? Questions?
Yes. Where is the R? Is between the negative 0.3.
Right. So R has to be calculated using a formula. We haven't gotten that part yet.
Okay.
You can't tell R just by looking at a scatter plot. What we'd have to do
Okay.
is take all of this information and run it through the complicated formula that you don't need to know, and then we would arrive at that coefficient, R equals point or negative 0.4 or whatever it might be. Okay.
Okay.
Yeah, so don't worry. You're not going to need to know the formula. You're not going to have to memorize it. You're not going to have to plug data into it. Not going to have to do any of that. There's a few things about the formulas that I'm going to suggest knowing, but we'll get to that here in just a minute. Okay.
I've seen it before, so I know what you're talking about. So I've
Yeah.
seen it before,
Yeah.
but as long as I know I ain't got to use it, I'm good.
Yeah. No, I feel confident enough that you're not going to need to know how to use it, that we're not even going to cover it. Okay.
Okay, thanks.
So just like there's a perfect positive correlation, there's also a perfect negative correlation. And a perfect negative correlation is our R is equal to -1. Okay, so those variables are moving in opposite directions perfectly with a lot of predictability. Again, this is very rare. We're not really going to see this um, in counseling research. There may be other types of studies where it happens more frequently. Okay, so we've understood negative correlations and positive correlations. And now let's look at no correlations. Okay. Some examples of there not being any correlations. So there's no correlation between an individual's shoe size and their counseling skill. Right? They're just not related in any way. There's no correlation between a high school student's locker number and the level of anxiety that they have. There's no correlation between coffee preference and an individual's GPA. Okay. Would knowing X, like locker number, help predict Y, their anxiety? The answer is no. There's no way of predicting one for the other. And this is what that type of scatter plot would look like, right? No predictable relationship. We don't see a trend moving positive or negative. Our R is going to be right around 0, showing that there's no relationship. Does this make sense? Maybe it will help to see a comparison chart, okay? So hopefully this isn't too small. But here we can look at both the correlation strength as well as the direction. Okay, so we're moving all the way from a perfect negative. You see how predictable this is? Those scatter plots are always falling on the line. Every time X increases, Y decreases. So we're moving up on the x-axis and down on the y-axis perfectly. R equals -0.1, perfect negative. Okay. A strong negative would be, for example, R equals -0.75, right? It's not, our cluster line is still definitely trending downward, but sometimes it's going up and sometimes it's going down. Here with moderate, it becomes a little more spread out. And then we get to no correlation where there's no semblance of a line at all. And then we move in the opposite direction with moderate positive, strong positive, perfect positive. We can also have weak negative and weak positive. They just aren't included on this diagram. Okay. So does this make sense? Are there questions about correlations? What are we wondering
Yes,
here?
yes, it does. It makes sense,
Okay, good.
especially now that I see the bottom where the negative 1.0 is and the
Yeah,
positive 1.0. That
right,
makes a whole lot more sense.
right. And so when we were talking about 0.85,
Right.
negative 0.85 would fall somewhere between -1 and negative 0.75, right? Because all the numbers that are less than zero, they don't actually increase, but they appear to increase in number as we move further to the left.
I get it.
Okay? So that's about relationships, right? We're looking at two variables, and does one variable affect the other? That's all that correlations are. And again, correlation does not prove causation. Okay. So let's talk really briefly about the formulas. There's really just two correlation types that we need to know or be familiar with. We're not even going to know them. We're just going to be familiar with them. Okay. There's a Pearson row, or sorry, Pearson R and a Spearman row. And these are used for two different types of data. When we're doing research and we're looking at correlation coefficients and we're using data that is interval or ratio determined, we're going to use the Pearson R formula. If you're looking at data that is ordinal or ranked, we're looking at the Spearman row correlation type. Here's what I mean by that. So with Pearson R, we're going to use this with anxiety scores, study scores, exam scores, right? Because they're interval numbers. There's a continuous numerical variable, right? Between each score, there's a very precise number in between them that can be calculated. Whereas with the Spearman row, we're looking at ordered categories like first, second, and third. How far is in a race, like if we're thinking about this in terms of a race, how far is the second place contestant from the first place contestant? Do we know? It's going to be different. First, the difference between first and second could be minutes, and the difference between second and third could be seconds, right? First place finished the race in 5 minutes. Second place finished the race in 6 minutes. Third place finished the race in 6 minutes, 5 seconds. So ordered categories don't have a specific interval. And that's when we would use the Spearman row correlation type. And that's as deep as I recommend you understanding these, right? Don't try and memorize these formulas. Just know when we would use Pearson R and when we would use Spearman row. If we have actual interval related data, we're going to use the Pearson R. If we're looking at ranks or ordered or ratios, that's when we're going to look at use Spearman row. Okay, and again, those represents formulas for calculating the correlation coefficients. Did I just confuse things with that?
No.
Okay. So if you were to be asked, how do I calculate the correlation coefficient? What's the first question you would need to ask?
Is there an interval or not?
Right. Does the data have an interval or not? And if it has an interval, we're going to use the Pearson R formula. And if it's just ordinal data, like first, second, third, and fourth, we're going to use a Spearman row. It's that simple. Okay. Okay. We're going to transition away from correlations unless there's any other questions. Okay. So the big question with skew is, do real counting variables always form perfect bell curves? And the answer, of course, is no. Many variables are going to produce skewed results, and we have to know, what do we do when it's skewed, right? So when one tail, remember talking about the curve, the tail is the part on the ends. When one tail becomes longer than the other, The tail tells the tail. That's the phrase I want you to remember. This is the mnemonic device. The tail tells the tail means that the mean, we talked about means last week, the mean average is going to go in the direction of the tail. Okay, so on a positive skew, you can see from this curve here, most of the scores are down here on the low end, right? If this is an anxiety score, most of the scores are low anxiety, right? But there's a few students that have extremely high anxiety. And so what that does is it kind of destroys our perfect curve. And most of the students have low scores, but there's a few that have high. So it skews the results positively. Does that make sense? There's a few students that have severe anxiety. And so rather than the same number of students having severe anxiety as have very low, with most of them clustered in the middle, most of the students have very low to moderate anxiety. Okay. What this looks like with the data is that the mean, our average that we figure out with the mean, is pulled towards the right side because of these higher scores. In a positive skew, the mean is greater than the median. What's the median? Do y'all remember?
That's the middle.
Middle, yeah. The mean is greater than the median, and the median is greater than the mode. Can we see that from this diagram? If our scores range between 0 and 100, let's say we had a score of 0, we had a score of 100, what's our median going to be? We'll be right here in the middle, like 50, right?
50, yeah.
Yeah. So
But what about the mode though?
well, what about the mode? We don't
I mean,
know exactly what the mode is, but if we had to guess based on this, what about where is our mode? We were to draw a line going straight here from the peak of our curve straight down.
Like 15.
15.
Yeah, it'd be like 15, right? We don't have it exactly because our scale here doesn't have it. But the mode would be about 15 because that's what most students scored. But the middle score, the median, is going to be right around 50. But our average is going to be higher than that because of all of these high anxiety scores. It's going to skew the results positively. If we took the top 5 scores off, right, and instead of this arrow going almost all the way to 100, it was over here to 70. If the top score was 70 instead of 100, that would make our mean lower, wouldn't it? Yeah. So that's what happens with the skew, is that our mean, our median, and mode go from greatest number to lowest number. Whereas in a normal bell curve, they're all the same. The mean, median, and mode are the same number. So similarly, with a negative skew, here we've got most of the scores are high with a long tail extending to the left. Okay, so we're looking at exam scores. Maybe most of the students have high scores that are clustered, down here towards 80, 90, 100. But there's a few students that had very low scores. So those low scoring students, because they scored so low, what did that do to the average score? Did it raise it or lower it?
raised it.
These students that scored low, their low scores lowered the average. Right? Does that make sense? If we didn't have these low scores, the average score would be closer to this high end. But because we have these low scores, that brought the mean lower than the median and definitely lower than the mode. If we had to guess, just basically looking at this chart, what would we guess the mode score was? About.
Maybe like 85.
Yeah, maybe 85. Yeah, we could 80, 85, somewhere around there, right? That's our mode. Which score was most? We look at the top of the curve, that's the most. But we can see clearly here that some scores were all the way up here at 100 and some scores were all the way down here at 0. So what does that tell us about our median? It's going to be right around what? Right around 50. So our mode is greater than our median. And thanks to these people who scored very low, our average, our mean, is also lowered. Okay? That's a negative skew. So the tail tells the tail. We want to ask, where is the tail? Is the tail on the left? And that's going to be a negative skew. If the tail's on the right, that's going to be a positive skew because the mean follows the direction of the tail. Okay, questions about this? We understand how we go from a normal distribution. We have people on one end, either the positive end or the negative end, scoring, and it skews the curve one direction or the other. Okay. All right, so how do we determine what the skew is? Okay, you're not going to have to do difficult calculations on the test, remember? But the degree of skew, to find that, we find the mean and we subtract the median, and that's going to tell us our skew. Okay, so if the mean is 50 and the median is 40, what's our degree of skew?
10.
10, because the mean minus the median equals 10. If our mean was 8 and our median was 12, what's our skew going to be?
-4.
Negative what?
-4.
Negative 4, right? Negative 4 would mean a negative skew. Can you picture a negative skew with the tail on the left? Yeah. 50 minus 40 is 10. That's a positive skew, so the tail is going to be on the right. Okay. Again, that's just helpful for interpretation. You're not going to have to calculate difficult things on the test, right? It'd be very simple arithmetic, okay? So skew matters because it changes how we interpret. It changes the averages that are used, right? Which impacts the conclusions that we draw. All of those percentages that we hate to learn from the bell curve, we don't have those with skewed curves, right? Those percentages represent how many people fall within those standard deviations, but we don't have any of that with skew. I mean, there's no standard with it. There's still percentages, but we don't have anything to learn there. Does that make sense? Right? The curve has been skewed, so those percentages don't tell us how many people scored within each deviation from the mean. If we ignore skew, then our research can be misled to incorrect conclusions, and that's why this is important, okay? So let's interpret this. We've got two different groups. Group A has a mean of 45 and a median of 44. Group B has a mean of 70 and a median of 50. Which group appears more skewed?
Group B.
Why do you say that?
Well, if you subtract the median from the mean, it leaves you with 20. That's for Group B, and the mean for the median on Group A is 1.
Right. Right. So there's more skew with group B. What if it was a mean of for group B, a mean of 50 and a median of 70, which would be more skewed?
I mean, Group B would be more negatively skewed, though. Maybe, you know what I mean? So,
Right. Right. So it would still be more skewed. It would just be negatively skewed, right? So the degree of skewedness, and there's probably a better way of saying that. The degree of skewedness is how far from zero the skew is. So a negative 20 is further from zero than a positive 1. So negative 20 is going to be more skewed than a positive 1, even though it's a negative number. Okay. And so what does that mean as far as our data? If we had a 20-degree skew versus a 1-degree skew, what does that tell us about the sample that we're studying?
Is it positive or negative?
It's
Is
going to
what
tell us if
you're
it's positive.
asking?
That's one observation that could be made. Yeah, a negative 20 is going to be a negative skew, and a plus 1 is going to be a positive skew. Think in terms of outliers. What would that tell us about outliers? If there's a strong skew, right, of negative 20, a strong negative skew versus a skew of just 1, which one is going to have more outliers? Outliers are further from the cluster.
The negative 20, don't know.
Right. Yeah, the negative 20. Right? Because more people scored further away from the average. Okay. Good. Those are some difficult concepts, but these are highly testable, right? That correlation does not equal causation. Understanding positive versus negative, the direction of skewed isn't the same as the strength. Same with the correlations. That we're using Pearson for intervals and ratios, and then we're using the Spearman-Rowe for ordinal data. I think earlier I misspoke and said ratio was Spearman, but it's not. And then the mean, the average is going to follow the tail in the direction of skew. Okay, so pay close attention to those concepts, as you're reviewing. Okay. Okay, do we need to go over anything? Are there any questions before we look at some practice questions?
Okay, one more. The
Sure.
spearmint is ordinal. And what did you say to think about the spearmint as?
So when we're thinking about Spearman-Rowe, if we are using that, it's because our data does not have intervals. First, second, third, and fourth doesn't tell us anything about
Right.
how
Okay.
far first is from second. So
All
that's
right.
what
So
the
think of it
Spearman.
as a race.
Yeah, a race is a good one. Or think about like doctorate versus masters versus bachelors, right? We might say one is a more advanced degree, but does that tell you anything about how many more years of school somebody with their doctorate has than their master's?
Indeed. Okay.
Yeah, I mean, generally we don't know. We could probably guess about how many, but those orders of magnitude are not measured in any sort of predictable intervals.
Okay.
Okay, you got this. We can do it. Any other questions?
Oh, I got it. I
Oh, you
got it.
got it.
I just
Awesome.
wanted to
Good.
think of how to remember that
Yeah,
because spearmint, and row.
sure.
I got
Yeah.
another name for spearmint and row.
Okay, well, yeah. All right, let's look at some practice questions and see where that takes us. Okay. A researcher finds R equals negative 0.72 between social support and burnout among community mental health counselors. Okay, our correlation of negative 0.72. Which interpretation is most accurate? Higher social support causes lower burnout. Greater social support tends to be associated with lower burnout, and the relationship appears to be moderately strong to strong. Burnout causes reduction in social support, or the relationship is weak because the value is negative. What do we think?
A.
I'm gonna say B.
Okay.
I say B as well.
Okay. So the correct answer is, for people to lock them in, the correct answer is B. Okay. Why would it not be A?
Well, I was approaching it from the standpoint that um, uh, um, when it one increases, the other decreases.
Right.
And I was looking at the lower burnout as negative 72. It
Uh,
is further away, but I
Yeah.
think I understand B.
Okay. So, Deb, the way that you're looking at this is right. That as social support increases, burnout decreases, which means it's a negative correlation, right? 0.72 is moderate to moderately strong, right? It's not like super strong, right? But it's also not super moderate. The problem with A is that it has in it this word causes. And correlation does not equal causation, right? So we couldn't say
Yeah.
high social support causes lower burnout. We can say there tends to be an association between higher support and lowering burnout, but we can't say that it causes it.
Thus, it's a reading test.
Yes, yes. Yeah, and in this case, causes is one of those words that's automatically going to eliminate A, it's automatically going to eliminate C, right? Because burnout causes reduction in social support. If we're talking about correlations and you see causes in the answer, that's an immediate no-go.
Yeah.
Okay.
Okay. Yeah. I was getting the cart before the
Yeah,
horse.
no, that's
And
okay. Your thinking was right. We just didn't have that connection about causation in there, right? D is wrong. The relationship is weak because the value is negative. Well, negative doesn't mean weak, right? There can be a weak negative, there can be a weak positive. Okay, good. The school counselor ranks students according to perceived school belongingness. 1 equals very low, 5 equals very high. The researcher wants to examine the relationship between belongingness rank and dropout risk rank. Which correlation coefficient is most appropriate? Okay. Why are we all saying C? You're correct. Ranking. Yes.
Well, for starters, it's the right answer.
That's
But
right.
but
That's
it's
right.
not. It's not talking about intervals or ratio.
Right. How far is very low from somewhat low?
It's a good
Right?
question.
Yeah, we don't know that, right? And
How
so
short is short?
how short is short? Exactly. That's a really great way of putting it. Um, because we don't know how far very low is from very high, there's no intervals provided. We would use the Spearman-Rowe correlation. Does that make sense? Yeah, there's no data that's collected. There's not been an assessment, there's no answers. We just have to kind of go based off of this school counselor's ranking. Rank is going to be Spearman-Rowe. Okay. A counseling researcher observes a mean of 78, a median of 65, and a mode of 58. Which conclusion is most supported? Distribution is positively skewed, distribution is negatively skewed, distribution is symmetrical, where no interpretation can be made.
Would it be A?
Are you asking me or
That's B.
telling me?
It's B.
I kind of want to let you guys duke it out and see who's right. is okay. Look at the data. The tail tells the tail.
I'm choosing B because the scores are low.
Okay. So think about this in terms of the mean. That's probably one of the most important things to look at in this one. How does the mean compare to the median and the mode?
It's
It's
higher.
higher.
Higher. And what does that tell us about the skew?
Positive.
That's
Positive. Yeah.
Right. That's why I said A.
Yeah. Yeah,
that's
you're
why the
right.
humpy is, right, Josh?
Yeah, so because the mean is higher, the mean is going to tell us where the tail is. Right? The mean tells the tail, or the tail tells the tail. Sorry.
I understand now.
Okay, good. Yeah. What does it mean that see here that it says the distribution is symmetrical? What type of what would that look like?
I mean, it's even.
It's even?
I don't
Yeah.
know.
Would it be
I guess.
okay? Yeah, be the one that we saw that just had all the. They were all together and they were neither up or down, neither positive or negative.
Yeah. If the distribution is symmetrical, then that's going to look like a normal bell curve,
Okay.
right? It's like a mirror image. The right side's the same as the left side. A symmetrical bell curve is predictable. We've got the percentages. That's what we want. Researchers studying therapist compassion fatigue report a correlation of plus 0.05. What is the most reasonable interpretation? A strong positive relationship, a moderate positive relationship, little to no meaningful relationship, or a perfect positive relationship?
Would that be B?
Okay. What are we looking at here that's helping us make a decision?
Oh, because it's a positive. So it maybe is D.
Okay.
Perfect will be 1 though, right, Josh?
Perfect would be 1. Perfect
So it's
positive.
A then, right? If it's not 1.
So this
I
one's
mean B.
I
It
was
will be,
saying,
wait a minute, I'm
I was
confused.
thinking
Hold on.
C. Yes.
C.
It's
Okay.
C, little to no meaningful
Little to no.
relationship.
Why is this little to no meaningful relationship? Because 0.05, let's go back here and look at this one.
It's not the same as 0.1.
It's not the same as 0.1. In fact, it's
It's
very
less
far from
than.
0.1. It's about as far from 0.1 as you can get before you go negative, right? 0.05 is right here.
Right. Okay.
Right?
Yep. That's what I thought. I was
Point,
thinking.
yeah, 0.5 is right here. 0.05 is right here, right? So little to no correlation. Just
Little.
because it has a positive on it doesn't mean anything if it's not far from the zero. Okay.
That's a question where it's easy to overlook the
Mhm.
0.05 versus the 0.5.
Right.
Yes, Deb. Deb.
Yeah.
You got it.
And if you're thinking, oh, 0.5, what would the correct answer be? 0.5 would be a moderate positive relationship, right?
Right.
So this is what's going to happen on the NCE is that if we misunderstand the question, there's going to be an answer that matches your misunderstanding, right? Everybody say, dang it. Because that's what's going to happen is that we're wanting to make sure, do we understand that 0.05 is different from 0.5? How are we going to know that? Well, let's throw 0.5 as a moderate to see if that throws people off or if they get the actual right one. I don't think they're trying to trick you. They're trying to differentiate people who know 0.05 from 0.5, right? It feels tricky, but it's just how they know that you actually know this concept.
It's a reading test.
It is a reading test. Yeah, we got to pay close attention. A counseling researcher reports clients with higher resilience scores tend to report fewer depressive symptoms. Which correlation direction is most likely? Positive, negative, no correlation, or perfect correlation? Take a guess if you don't know. If you don't guess, you're sure to get it wrong. Okay. So when we're looking at correlation, if both variables are moving in the same direction, that's going to be positive. Okay. If one is moving in one direction and the other is moving in another direction, that's going to be negative. So what do we have happening here? Are they both moving in the same direction or are they moving in different directions?
Different.
Different, right? What's happening to the resilience scores? Are they going up or down?
Up,
What's happening to the depressive symptoms? Are they going up or down?
down,
Down. So that's a negative
negative.
correlation. As resilience goes up, depression goes down. That's a negative correlation. Okay. It's not, so why is it, let me ask you this. Why is it not a perfect correlation? Why would that not be the best answer here?
It says tend to report.
Tend to. What in the world does that mean? Right? If it said every time a resilience score goes up by a point, depression scores go down by 2 points. Every time. Then we could predict and we'd say that's a perfect correlation, right? Up one, over one, up one, over one. Okay. The data set shows most participants cluster around high scores, while a small number have very low scores. Which distribution shape is most likely? Positive skew, negative skew, symmetrical distribution, or a bimodal distribution?
Well, it wouldn't be C because you said C is when it is even, right?
Good, yeah. Process of elimination. C would not be the correct answer because symmetrical means that it's the same on both sides. So good. Okay. Any other answers we can eliminate? We haven't talked a whole lot about bimodal. What does that mean?
Well, it would be two groups, right?
Yeah, it'd be like a double
the
humped
same thing.
camel.
Yeah.
Yeah, bimodal would be like an M-shaped curve. Up.
So we can rule that out.
We can rule that out. So it's between A and B, positive or negative.
Well, it says most participants cluster around the high score. So
Okay.
would it be positive? Would it be A?
Positive.
If
Would it be
most of
A?
the participants are on the high side, is the high side going to be the right or the left?
Right.
It's
Right.
gonna be on the. It's gonna be on the left.
Most of the scores are going to be on the high side,
Oh, yeah. Right. It's going to be on the right.
right? And
Mm-hmm.
so because there's a few scores that were lower, And most
So
of
it'll
them
be a
are higher.
negative.
Yeah. So is that a positive or a negative skew?
So it'll be negative skew.
Right. Oops. Where am I at here? That'd be negative skew.
Okay, so most participants cluster around the high score, and being as though that's on the right, so the tail is going to come down on the left, which make
Correct.
it the negative. Okay.
Yes. Yes, that's correct. Here, let me show you the chart one more time. Right? So we're looking on this left-hand side. Most of the
Uh-huh.
scores are high. There's a
Mm-hmm.
few
Okay.
low scores.
Okay. Yeah.
Hmm. Very
Because
tricky.
yeah, the low scores are going to bring the median, or sorry, the mean down.
Mm.
The mean is going to be less than the mode. Okay, good.
Mm-hmm.
Okay.
Does this go back to what you were saying though about negative being one goes up and one goes down? Because wouldn't that apply to that question?
No. So
Uh,
Lauren, you're talking about correlation. Yeah, correlation
because
and
that worked
skew.
for my answer though, but I couldn't apply that.
It worked this time. It worked this time. Yeah, and that's why I mean these are two different concepts, right?
Okay.
Um, and there's not a real simple way of bridging that gap between the two of these. Okay. So we
Okay.
have we have just different things that we're measuring here. Okay. But yeah. Okay, researchers find a correlation of negative 0.91 between treatment adherence and hospitalization frequency. Which statement is most accurate? A very strong inverse relationship exists, though causation remains uncertain. Treatment adherence perfectly prevents hospitalization. Hospitalization frequency causes adherence changes. The relationship is weak because values are negative. What do we think? Okay. So remember this number, the correlation coefficient is negative 0.91. Okay. At negative 0.91, where do we plot that?
Close to negative 1.0.
Close to negative 1. Is it perfect negative?
Not perfect, but it's almost.
That's almost. And what do we call it if it's not perfect?
Strong.
Strong what?
Negative.
Strong negative.
Strong negative. Okay, keep that in mind. Let me get back to it here. So we've got a strong negative. Okay.
Mm-hmm.
Um, is
So it
that
wouldn't be D because it say weak.
right? So it's not going to be weak because just because it's close to negative 1,
So
it's going
it'd
to be
be
strong.
A
Be A. Why would it be A?
because it says it's very strong.
A very strong, and inverse is another way of saying negative. Inverse means as one goes up, one goes down.
Hmm.
Okay. So as treatment adherence goes up, what comes down?
Hospitalization.
Hospitalization frequency.
Hospitalization.
Yeah. As people adhere to treatment, their level of hospitalization goes down. So much so that it's a very strong inverse relationship, right? Could we say that treatment adherence causes hospitalization frequency to decrease?
No,
No, why couldn't we say that?
because it's just looking at the treatment adherence in the hospitalization frequency, not what causes it.
Right. Correlation does not relate to causation. There's an association, but we can't say that it causes it. Okay. Good. I think we got two more here. A researcher states the mean appears substantially lower than the median. What should be suspected first? Positive skew, negative skew, no skew, or a perfect normal distribution? Hey, the tail tells the tale, right? So if if our mean is lower than the median, that means the mean is to the left of the median. That means our tail is going to be to the left of the median, so it's a negative skew. Okay, good. All right. Counseling outcomes study finds a correlation coefficient of plus 0.68 between session attendance and symptom improvement. Which interpretation best separates strength from direction? Is this a strong negative relationship, a weak positive relationship, a perfect positive relationship, or a moderately strong positive relationship? Okay, very good. A moderately strong positive relationship, right? It's not super strong, it's just moderately strong. Because 0.68 is not on the far right-hand side of that graph. Okay, last one. Researchers studying coping skills notice most participants score similarly, but a small number score dramatically higher than everyone else. The researcher reports only the mean. What is the best critique? The mean may overestimate the typical participant because extreme scores pull it towards the tail. Means cannot be used with psychological variables. Means eliminate skew effects, or skew only affects standard deviation. All right. Thanks for guessing, Bridget. You guessed correctly. Good. Yeah, so when we look at a skewed curve, the mean is going to reflect the lower scores being factored in, whereas most of the scores are, in this situation, most of the scores are going to be lower than the average, right? That's why when you were in school and you had that one kid in class who always got hundreds, and the teacher would say, Johnny just blew the curve, is because instead of scoring with the curve where most people got, that high score just kind of blew the averages out of the water, right? Johnny. Yeah. Okay. All right. Questions about